Hi, welcome to the Neuro Revision Lab. It's time for the second version of the rates of reaction practical, the sodium thiosulfate reaction, also known as the disappearing cross. Don't forget to subscribe, punch the like button, and let's get started. First, there are a few things you need to know. Collision theory and rates of reaction. You should be able to, by the end, recall the method for investigating the effect of concentration on rates of reaction, plot a graph of your results, and explain the results in an extended answer. Keywords unique to this practical are turbidity, rate of reaction, dilution, precipitate, disappearing cross, and control variable. Take a moment to write these down in your books, practice spelling and sounding them out, and listen carefully to how these words are used and research their definitions later. This is by far one of my favourite practicals. By reacting sodium thiosulfate with hydrochloric acid, you produce sodium chloride, water, sulphur dioxide, and solid sulphur. As the reaction continues, the sulphur precipitates out, making the solution cloudy. It's very important to do this in a well-ventilated room though, because sulphur dioxide, which is also produced, is dangerous to breathe in and smells absolutely awful, like rotten eggs. Here's a really accurate picture of the method. It's useful for understanding how we did it, but not simple enough to sketch as a memory aid. So let's make it simpler. The variables that we're going to use are the independent variable, which is the concentration of sodium thiosulfate we're testing. The dependent variable, which is the time taken for the cross to disappear. The control variable, which can be the volume of acid, concentration of acid, temperature, and the same person observing the cross so that we avoid observer bias. Method. Measure 50 centimeters cubed of sodium thiosulfate and pour it into a conical flask. Place the flask directly on top of the printed black cross. Measure 10 centimeters cubed of dilute hydrochloric acid and pour the acid into the flask. The second you do this though, immediately start the stopwatch and give the flask a little bit of a swirl. Look down through the top and stop the clock the moment the cross disappears. Record the time in seconds in your results table. Repeat step 1 through 5 with different concentration of sodium thiosulfate. Now there's a couple of errors that can be made here. Here's a common results table from a recent experiment. Because random error can affect this one so badly, we do 3 trials and calculate an average time. In GCSE questions, you may be asked to identify or exclude an outlier, a result that doesn't fit the pattern. Dyslexic learners, you'll be great at spotting these. Now it's time to practice drawing a graph. Pause the video if you'd like to do this yourself. Here's what the graph would look like. As concentration increases, the time for the cross to disappear decreases. The conclusion we can draw here is increasing the concentration also increases the rate of reaction, though I suspect we probably already knew that. At this point, your revision notes should look similar to this. If not, take a little bit of time to update them before moving on. Okay, so exam question. Now, a required practical exam question usually takes up the last portion of a long extended part of the question, so they're worth quite a few marks. First thing you're going to want to do is highlight the command words. What is this question actually asking you to do? And then it helps to highlight the keywords. There are no values here, so you won't need to do that. Question A. A student investigated the effect of changing the concentration of sodium thiosulfate on the rate of reaction with hydrochloric acid. The student completed the experiment 3 times to gain an average. What sources of error might be found in the method? You should state at least one control variable in your answer. Question B. The student determined the rate of the reaction increased as the concentration increased. In terms of particles, explain why this statement is accurate. For more revision resources, tips and materials, visit the Neuro Revision Lab store. Everything is designed for neurodivergent learners, and purchases support the channel so that we can keep making content. Subscribe and punch the like button. So let's take a look at these answers. This question, question A, focuses on control variables. You could pick any of them really, but the most common is temperature. A warmer room increases the reaction rate. As well as this, a common source of error in the disappearing cross experiment is that some people may interpret the disappearance of the cross differently. That's why the same person should always observe it. Question B. Now this one might be a little bit familiar because it was in our last video, also looking at the other required practical question. The student determined the rate of reaction increased as the concentration increased. In terms of particles, explain why this statement is accurate. Firstly, a higher concentration means there are more particles in the same volume. Because it's more crowded, the particles are closer together. This causes more frequent collisions, and this leads to more successful collisions per second, which means the rate increases as well. Well done! That completes the rates of reaction revision. If this video helped, hit the subscribe and like buttons below. Also, check out our store for books designed for neurodivergent learners. They're excellent for EHC plans and include features like the Cornell note-taking system, pastel colors, and a whole host of other very useful prompts inside. See you next time on the Neuro Revision Lab.